Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now here I want to explain the chapter that is redox reaction of 11th class chemistry. Actually it is very important for the 11th class, not only 11th class but also for 12th class. In 12th class this chapter is indirectly converted to electrochemistry. First of all, we see what is meant by redox reaction. But if you go to what is meant by redox reaction, it is very difficult. So from the simple, we will go to complex. From the simple one, that is what is mean by oxidation, reduction, electron transfer, all the things a little by little, then we proceed to redox reaction easily. Generally, students of 11th class, they feel it is very difficult. But actually this chapter is not so difficult, but actually you will proceed from simple to complex, then only we feel it is very easy. Now in this case, this is chapter redox reaction and part 1. First we will see what is meant by oxidation reaction. Then we will proceed to what is meant by redox reaction. Now see what is meant by oxidation reaction. In lower class, just like 9th class and 10th class, what is oxidation reaction? Only addition of oxygen the students remember. But now we will expand this one. What is meant by oxidation reaction? First step, that is very simple. What is meant by oxidation? Addition of oxygen. Now see, addition of oxygen means oxygen to be added. Then oxygen to be added to where, and here it is known as oxidation reaction. Now see, carbon, which is a solid one, when oxygen is added, it gives carbon dioxide, which is a gas. Now this is also one oxidation. Similarly, magnesium, that is in ribbon form, solid, and when it bonds with the oxygen, here also it will bond, and in first reaction also the carbon bond with oxygen, it gives carbon dioxide. Similarly, magnesium ribbon bond in oxygen gives magnesium oxide. This is very simple. Where oxygen is added to the substrate, then immediately you can say it is oxidation. But when you proceed to second one, that is removal of hydrogen, in the reaction where we will see how the hydrogen to be removed, then see here, that is here hydrogen sulfide, that is a gas, and oxygen also gas. When they are both treated with each other, then what happens? Water is formed as a byproduct, and main product is sulfur, which is solid form. Now what happens? You see, in hydrogen sulfide, the sulfur and hydrogen both are there. Now here hydrogen is removed. Here hydrogen removed and it changes to sulfur. Since hydrogen is removed, and that is why it is one example of oxidation reaction. Similarly, hydrochloric acid. Hydrochloric acid, when oxygen is passed through it, it gives water and chlorine gas. Now you can see hydrogen chloride, that hydrochloric acid, when it contains hydrogen. But after the reaction, here hydrogen is removed and changes to chlorine. Then what happens here? It changes to chlorine, means there is hydrogen, that one is removed. From where? From HCl. From where? From hydrogen sulfide. That is why it is both are example of oxidation reaction. Then addition of electronegative element. Then what is meant by electronegative element? There are two types of elements. One is electropositive, another one electronegative element. In periodic table, electropositive means generally metal part, first group, second group. Whereas electronegative means that is non-metal, that means here 16 and 17 groups, they are generally known as electronegative elements. Now here chlorine, sulfur belongs to 16 group, chlorine belongs to 17 group. Now easily you can remember electronegative elements. That means they have tendency to accept electron. But this sentence again I will explain in next class. Now magnesium, that is in ribbon form, when chlorine gas is treated, and what happens? Magnesium chloride is formed. That means you will bond this one and it gives magnesium chloride. Similarly, magnesium, that is in solid form, that is ribbon, when it bonds with the sulfur, it gives magnesium sulfide. Now you can observe the chlorine, which is electronegative element that belongs to 17 group, sulfur also electronegative element belongs to 16 group, both are added in magnesium and gives the respective product. So easily you can say yes, this is one example of, both are one example of oxidation reaction. Now see, removal of electropositive element. Just now I told what are the electropositive element, that means first and second group. So first and second group, the element, the metals which are called electropositive elements. Similarly, here you take potassium iodide solution, that is aqueous, chlorine is gas, that is in gas form. When they pass through the aqueous solution of potassium iodide, that is a potassium iodide which is colorless, and it gives here potassium chloride solid form. It is soluble. So it is, you should write aqua, because potassium chloride is soluble in where, in water. So here also magnesium chloride also soluble in water. Then what happens? An iodine. Iodine is formed, that means violet color you can observe. That means here addition of electropositive element, that what one? That is, removal of electropositive element, that means potassium is removed. Potassium is removed, only iodine is there. That is why it is known as oxidation reaction example, and here the cause is removal of electropositive element. Electropositive element, which one? Potassium. Where? In potassium iodide solution, by the help of what? Chlorine. And chlorine is not responsible for the word oxidation, only potassium where it is removed and it gives iodine, I2. So again see, first one addition of oxygen where oxygen is added, second one removal of hydrogen where hydrogen is removed from the substrate, and addition of electro negative element, directly you can observe 16 or 17 group elements is added. That means it is sure that it is one type of oxidation. And removal of electropositive element, that means from the substrate, if the electropositive element, that means first group and second group of the periodic table, if it is removed, then it is called oxidation. Further also we will see other examples of the oxidation reaction. Now we will see what is meant by reduction. Before that, one point is that is increase of positive valency, that is also important point for oxidation. Increase of positive valency. Positive valency means here example K0 means valency is 0 when it is in elementary stage, that is 0. When it loses one electron and it changes to K plus. K plus means potassium ion, positive ion. Then how it will form? Now potassium, that is proton is 19 and electron also 19 because atom is neutral. When one electron is removed, then after that what happened? Proton 19 plus and here electron 18 minus. So what is the net result? That is plus 1. What it indicates? If one electron lost, that means here one positive valency increases. Now see here Fe plus 2. Fe plus 2 when loses one electron, again it will increase one positive valency. Here also you can observe magnesium 0. That means in elementary stage magnesium has 0 valency. When it loses 2 electron, it occupies plus 2. How many electron lost? That means that the same number of increase of positive valency. That means here loss of 1 electron increase 1 positive valency. Loss of 2 electrons increase of 2 positive valency. Similarly, how many electron one metal or one element it loses, that is the number of the positive charge. Then after that, now here oxidation is completed. Then come to what is meant by reduction. See here what is meant by reduction. First point, just opposite to oxidation. In oxidation I told addition of oxygen and removal of hydrogen. But here just opposite, addition of hydrogen, removal of oxygen. Addition of hydrogen, here hydrogen is added to oxygen and it forms water, and here you should write the gas, and also it is gas and it is liquid. Similarly, it is also chlorine is gas, hydrogen is gas, and that is also gas. That means here you can observe addition of hydrogen taking place in both reaction. Here oxygen plus hydrogen gives water, chlorine plus hydrogen gives hydrochloric acid. That means here this is the main important point for reduction. The next point come to removal of oxygen. That means oxygen should be removed from the main substrate. Now see magnesium oxide, the formula MgO. When you heat it, it gives magnesium solid, and it is also solid, it gives oxygen gas. What is mean here? Oxygen is removed from the magnesium oxide. Oxygen is removed from the magnesium oxide. Similarly, oxygen is removed in second reaction, CuO, cupric oxide, and hydrogen, that is in gas form. It gives copper solid and water liquid. What happens? See here, you leave all the things, only you receive this one main important point that you will see for cupric oxide. In cupric oxide, what is the formula? CuO, oxygen is there, and here removal of oxygen. That means from cupric oxide, oxygen is removed and changes to copper solid. Cupric oxide also was solid, and after the reaction with hydrogen, it gives CuS. That means oxygen is removed from cupric oxide. Here this is the main change where oxygen is removed. See here, removal of oxygen. In this case, oxygen is removed from magnesium oxide. So here it is also one point for reduction. Now there are two types of definition. One is addition of hydrogen, second is removal of oxygen. I hope it is clear. Then come to second one, addition of electropositive elements. Just now I told what is meant by electropositive elements. In periodic table, first group and second group, the elements, generally metals, they are known as electropositive elements because they can lose electron easily and changes to positive ion. Similarly, here you can see you are adding iron because iron is a metal, though it not belongs to second group and it is a transition metal, but it is a metal. Any metal is one electropositive element because it can lose electron easily and forms to positive ion. That is why this is one case of electropositive element. When it is added to FeCl3 aqua, that means the solution of ferric chloride, which the color is light yellow color. Now when iron piece, iron solid is added to ferric chloride, what happens? It changes to FeCl2. That is here FeCl3 changes to FeCl2 after addition of electropositive element. Then come to last point for reduction, increase of negative valency. What is meant by increase of negative valency? Suppose it is -1, it changes to -2. That means increase 0 to -1. This is known as increase of negative valency, or you can say in reverse, decrease of positive charge. Let us see, Fe plus 3 changes to Fe plus 2. That means plus 3 changes to plus 2. Here you can see decrease of positive charge. Fe plus 3 changes to Fe plus 2, decrease of positive charge. Whenever you see chlorine that is having valency 0, after the gaining of electron, it changes to Cl minus, it acquires negative charge. That means what is the another very important point that is for reduction? This is the last definition that is very important. Here you can say chlorine, here the charge is 0, valence is 0, and now it increases negative valency 0 to minus 1. That means here increase of negative valency. And Or you can say, in some cases you immediately you can see, yes, here there is decrease of positive charge. Here Fe plus 3, if one electron if one electron gain, one per negative charge increases. That means here you can see plus 3 changes to plus 2 because it gain one electron. It gains one electron, that is why plus 3 changes to plus 2. Here also chlorine, there are 2 atoms, that is why 2 electron here it is gaining, so it is there 2Cl minus. That means one chlorine atom, if it is there, then it will receive or it gains one electron. So it changes to 0 to minus 1. So what is the conclusion here? You can say after gaining electron, the negative charge increases. After the donating electron or loss of electron, increase of positive charge. So these are the main important points for reduction and also oxidation. And now gradually we will jump to what is meant by redox reaction and oxidizing agent and reducing agent. I have already explained what is meant by oxidation and reduction. For oxidation, so many points are there, so many definitions are there. Similarly, for reduction, so many definitions are there. Now, we will see here what is meant by redox reaction. I have completed oxidation reduction. Now, we will see what is redox reaction. Redox reaction means where oxidation and reduction both take place simultaneously, side by side. One will be oxidized, other will be reduced. That means here where oxidation reduction takes place simultaneously in a reaction, and that is called redox reaction. In redox reaction, one substance is oxidized and other one is reduced. Suppose let if R1, R2 both are reactants, and here if I say it is redox reaction, then how can I prove it? That means if R1 is oxidized, then R2 should be reduced. So here R1 should be oxidized and R2B should be reduced. If R2 is oxidized, then R1 should be reduced. That means one should be oxidized and other should be reduced. Now, then come to what is oxidizing agent. Redox reaction means both oxidation and reduction takes place. One is oxidized and other is reduced. That means why one will be oxidized, why other is to be reduced. What is the reason? Actually, the word is there, oxidizing agent. What is oxidizing agent? Which oxidizes other and itself reduce. That means the oxidizing agent is one which oxidizes other and itself reduced. Examples came in NO4O2, Cl2, HNO3 like this. But oxidizing agent, where we will find in a reaction, we will find which one acts as an oxidizing agent and why. And this is also called oxidant. Oxidizing agent nowadays it is called oxidant. And the example of the reaction I will say in later in correspond to redox reaction, oxidizing and reducing agent. Now, oxidizing agent, here we can say let it is oxidizing agent. Then how can you say where reduction takes place? Oxidizing agent is one where reduction takes place. Let one example because I have not explained reducing agent, only I will say which one here oxidizing agent. After completing reducing agent, in a reaction we will see which one acts as a oxidizing agent, which one acts as reducing agent. Now see example, if this is one reaction, H2S gas, chlorine gas, it gives HCl gas, sulfur solid. That means here leave H2S, only you will see the part where we call oxidizing agent, that is oxidant. Cl2C here, it changes to HCl. Cl2 changes to HCl. What is the change? What is the change here? An addition of hydrogen takes place. I told addition of hydrogen is reduction. addition of hydrogen is reduction. And now the Cl2 is undergoes reduction and the product is HCl, where addition of hydrogen takes place. That is why we can say the process that is reduction. And if it is reduction, I told oxidizing agent is one where reduction takes place. That means chlorine is Cl2 gas, chlorine is an oxidizing agent in this reaction. See again, oxidizing agent mean which oxidizes other. How it will oxidize other we will see after completing reducing agent. Only remember here only Cl2 changes to HCl and reduction takes place, and that is called oxidizing agent. And why, and after that completing all I will explain after completing the reducing agent, and I will explain how that chlorine is an oxidizing agent. Now you remember only here chlorine is an oxidizing agent because reduction here takes place. Next I will explain what is meant by a reducing agent and examples related to redox reaction, oxidizing agent and reducing agent. What is oxidizing agent? That is clear to you. Oxidizing agent means is one which oxidize other and itself reduce, and they are also called oxidant. Now here what is reducing agent? Reducing agent is one which reduce others but itself oxidize. Now it is also called reductant. What is reducing agent? It reduces other and itself oxidize. That is why example you take stannous chloride, that formula SnCl2, SO2 and more salt generally used in practical, and now in titration and reducing agent. Then what is conclusion? Reducing agent mean where oxidation takes place. Which one is reducing agent? Where oxidation takes place, and which reduce other and itself oxidized. Now example, the same example what I have taken in oxidizing agent, same I put here. H2S gas, chlorine gas and HCl gas, sulfur solid. You observe here H2S changes to S. H2S changes to S mean here removal of hydrogen. Removal of hydrogen mean oxidation takes place. Similarly, and here chlorine changes to HCl. Here reduction takes place. Now we can say here H2S gas reducing agent because here oxidation takes place. Here oxidation takes place. Here the hydrogen is removed. That is why it acts as a reducing agent. It reduces other and itself oxidized to sulfur. Again see, H2S acts as reducing agent because it reduces chlorine to hydrochloric acid gas, and now itself reduced to itself oxidized to sulfur. That means I told a reducing agent is one which reduces other and itself oxidize. Now see, itself oxidize means hydrogen removed, so itself oxidize. So oxidation takes place. I told reducing agent where oxidation takes place. Similarly, chlorine changes to hydrochloric acid HCl. That means here addition of hydrogen takes place. That means reduction takes place. And here chlorine is an oxidizing agent because it oxidizes hydrogen sulfide to sulfur and itself reduced to hydrochloric acid HCl. So it is clear oxidizing agent mean which oxidize other and itself reduce, and that is example here chlorine, and reducing agent which reduces other and itself oxidize. Here hydrogen sulfide is changes to sulfur, and so it acts as a reducing agent. Now second example you can, that is very important example, and CuO, cupric oxide, that is solid, and here hydrogen, and the product is Cu copper solid and water liquid. You can observe CuO changes to Cu. What is meaning? Removal of oxygen. Removal of oxygen means reduction takes place. So Cu itself reduced to copper and it oxidizes hydrogen to water H2O. Addition of oxygen takes place. So oxidation takes place and here reduction takes place because oxygen is removed. So CuO acts as an oxidizing agent because here oxygen is removed and the product is Cu. And then what is I told oxidizing agent mean which oxidize other and itself reduce. See here, it oxidize hydrogen to water and itself reduce to copper. Similarly, hydrogen to water, that means what happened? Here addition of oxygen takes place. That means here oxidation takes place. If oxidation takes place, then what is the name of that H2? H2 acts as reducing agent because it reduces that neighbor copper oxide, cupric oxide to copper and itself oxidize to water. That means here which one oxidizing agent? CuO acts as an oxidizing agent because it oxidizes other means hydrogen to water. And here second one this H2 acts as reducing agent because it reduces copper oxide to copper and itself oxidized. Oxidation takes place. So here I have completed first one is oxidation. What is meaning by oxidation? So many definitions are there. Next is reduction. So many definitions are there. Wherever you can apply necessary it is that definition you can apply. And next is what is meaning of redox reaction. Redox reaction after that reducing agent and oxidizing agent, how they are related in redox reaction, how oxidizing agent and reducing agent both are related in a redox reaction. It is also completed. In redox reaction where the oxidation reduction both will take place simultaneously. One is oxidizing agent, other one is reducing agent. What is oxidizing agent, reducing agent? I hope it is clear to you. An oxidizing agent means which oxidize others and itself reduce, and reducing agent means reduce other itself oxidize. These are the main examples. Other examples you can see and apply your knowledge which one acts as oxidizing agent, which one will act as a reducing agent. I hope this part 1 where oxidation, reduction, redox reaction and oxidizing agent, reducing agent completed. I hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and also I hope you will like and share my channel. Thanks you all.